So now we are on letters B. We are now on letters C, D, and E. The football is kicked at 37 degrees from the ground at 20 meters per second, and it does form a triangle. And we solved that the opposite was 12.04. But this time, we're not solving for height or the time it takes to reach that height. We're solving for how far away it hits the ground. In other words, what is the total distance covered from the starting point to the ending point? In other words, we're trying to find what is the adjacent. Let's use SOHCAHTOA because this trajectory forms a triangle. And SOHCAHTOA is sine theta equals opposite over hypotenuse, or cosine theta equals adjacent over hypotenuse, or tangent theta equals opposite over adjacent. Since we're trying to find adjacent and we know the hypotenuse, we're going to use cosine, and cosine is 37 equals adjacent over hypotenuse. And when you find cosine 37 and you multiply both sides by 20, your answer is going to be 15.97 meters per second. So that is our adjacent. Our adjacent is 15.97 meters per second. That's the force it takes to travel across this trajectory. Now we need to solve for the distance it takes for the football to reach the end of the trajectory, because this force can be plugged into an equation. Now there's a mnemonic device where velocity, distance, and time are placed into a triangle, and if you solve for velocity, it's going to equal x, the distance over time. If you solve for distance, it's going to equal velocity times time, or if you solve for time, it's going to equal distance divided by velocity. And that's going to be what we're trying to find. Distance equals velocity times time. So we plug it in, and we get 15.97, which is the velocity, times time 2.46. That's from what we calculated in letter B. And the answer is 39.29 meters is the total distance. Now to find letter C, the velocity at maximum height is going to be 0 because the ball stops moving upwards when it reaches maximum height, and then it starts falling back down. The acceleration vector at maximum height is always going to be gravity. When an object is falling or rising, the acceleration is going to be acting upon it is gravity, negative 9.8 meters per second.